Okay. Mr. Dicky.
Hang.
Mr. Hank. Mr. Hank.
Hang.
Okay. So just take the attendance. Okay. So let's discuss tutorial 1. So tutorial 1, you will see question 1 and 2, 3 here. These are actually from yesterday's lecture. But when it comes to question number 4 here, I just put a little bit of the something like set and logic here, so that you can start practicing or start looking at what you have learned previously in your mathematics or whatever course that you have learned before. Because this kind of scenario, okay, this kind of symbol, okay, you may use for your course formal method later. Okay, so we are going to do some recap on those things that you have learned previously. Okay, so if you look at question number 1 here, and this is from past year question, so you can see these are something like you can refer to the past year question. This one is from, I think, last sem, past year question or previous sem, another sem previously. Okay, so one of the question is, of course, because when it comes to theory and so on, minimum level is C2. If you remember yesterday, I'm talking, okay? Minimum level is C2. So meaning that mostly C2 will be discussing, define, discuss, explain, all those things. That is actually C2 level. Okay? So one of the questions that you can see here is one Roman here, okay? So this is actually C2 level. Because asking you to describe means that it's your own, like, remember lah. So remember and then explain what you remember using your own words. So C2 level only. Okay, so yesterday we had a lecture. Now I'm asking you whether you remember or not what I taught you yesterday. So what do you remember from yesterday's lecture about formal method?
Formal verification and specification.
Okay, so you can discuss, okay, consists of formal verification and also formal specification. Okay, so means that when we talk about formal method, okay, you can do during the formal specification or also formal verification. So formal specification, the word specify there means that when you are talking about the specifying requirement. So mostly when we see the word formal specification, will be inside the analysis and design phase. Yeah? And then another one is formal verification just now. Verify. Verify means you are trying to check whether what you are doing there is actually correct or not. So that is verified. So when we talk about formal verification, so when you want to verify, normally you are not during the analysis, because analysis, of course, you have like you learn some requirement or whatever. You may have something to verify, validate during that time. But main point here, formal verification is to verify the whole thing that you have done. Okay, so normally formal verification is actually during the testing phase. Okay, testing phase, mostly during the testing phase. Okay, so that is one point about formal verification. Other than that, remember, C2 level. So what you remember? Formal. When we talk about formal, not formal where, formal means something that you have to follow. So means that something that provide you logic or whatever. So when we talk about logic, normally we are talking about the mathematical notation, mathematical symbol, set logic, algebra, all those things. So that is what you mean by formal method. So it means that when you want to analyze the requirement and so on, the way that you represent the result later will be using mathematical notation, such as logic, okay, such as algebra, your set theory, all those things that you have learned previously. Okay, so that is also what we say about formal methods. So when you see the word formal means something that formal, how to show formal is by using, of course, UML diagram that you have learned whatever will be formal also, but it's not totally 100% formal. Normally that one we call as semi-formal, because people can do differently on how to do their own diagram and so on. How you interpret the diagram, okay, might have different meaning for different people. Okay, but when we say about mathematics, plus means plus, minus means minus. You cannot do plus to indicate minus, cannot, it's formal. That's why mathematical notation will indicate that it is a part of using mathematical as a part of formal methods where you use mathematical notation just now, such as set theory, logic, true false, all those things like. Okay, algebra, all those things that you have learned previously. Okay, so that is formal method. So normally formal method, like what your friend said just now, formal specification, formal verification, and then how you want to translate whatever that you want to do, you use mathematical notation. So our formal method here, because our main purpose for formal method here, we are talking about related to software engineering. Okay, you can say about mathematical notation and like that, I cannot. Because when we talk about formal method can be normal, like formal method, mathematical notation, but what we are trying to say here, related to software engineering. So when you use formal method, you try to look in terms of the requirement, you interpret the requirement, and you produce the result using mathematical notation. Okay, so that's what you mean by formal method in software engineering. Okay, so you relate with software. Okay, not just formal method. Okay, mathematical notation, that's all. So how to relate to the software? Inside formal specification or formal verification. Then you can add your explanation using your own words. That one, but the key point is this one. Okay, so the key point is this one. So you can relate with phases like life cycle just now. Okay, you can relate also in terms of formal specification language. You can relate, okay, with other things. But the main key point when we want to explain is actually formal method and software engineering combined together. How you want to explain these two together. Okay, so that's actually how you interpret the question. Okay, because this is partial question. So normally I will look into this kind of answer when I mark the question. Okay, so the next one, useful. Why? Why useful in critical system? What do you think? Why is it useful in the critical system? This one you write down your own. I will not give it. Normally for formal method, for Z schema, whatever, I will give you sample answer. Means during discussion, I will write the answer. But for theory, you write your own answer. No need for me to write the answer for you. You write your own answer. Okay? So the next one here, reasons why. Okay, 3 reasons. Because this is normally, if you look at the past year questions, you have to write something like this, 3 with the bracket 3 like this. So why formal methods useful for critical system development? What do you think? What do you think? What do you think? Any of you?
Reduce risk.
Okay? Yes, reduce risk. Especially because the word here critical system. Okay, so critical system here normally we are talking about safety or security critical system. Safety critical or security critical. So one of the reason why you will go for formal method is to reduce risk. Okay, especially if you are talking about safety critical, reduce risk of losing human being life. Okay, kematian, whatever. So we try to reduce that kind of thing, reduce risk. Safety, you can talk in terms of people try to hack your system. So formal method, when you go for something like model checker and so on, they can check every reachable path. So every reachable path, so whatever happens inside there, you can try to prevent. We cannot say prevent 100% lah. We can try to reduce problem with that. Okay? Problem with people trying to hack your system, whatever, we are trying to prevent that lah. I cannot say 100% lah. You cannot prevent 100%. Any system in the world is not going to be 100% perfect. Nobody is perfect. So when nobody is perfect, how are you going to develop 100% perfect system? So we are trying to help on reducing the risk of either safety or security problem. Okay, so that is one of the reason. Any other reason? What do you think? What do you think? You can also, sorry?
Error detection.
Oh yeah, error detection. Okay? So critical system, when error prone or error detection, we are trying to go for formal method as early as possible, especially for critical system. Okay? Remember yesterday I talked yesterday about the train door, whatever. You are trying to prevent any errors occur as early as possible. Okay? So from here, you found out that because if you go for normal design, whatever, no problem. Actually, you can use like normal, like you use UML, normal design, whatever, no problem. Okay? It's not that that kind of system cannot be done with that. No, you can use. But formal method will be helpful to you. Okay? Because when you go for formal method, you are trying to do together, means complement each other. Okay? Complement each other means that you do the normal UML diagram, whatever that you design, all those things, normal way, like other system, but you complement it with formal method. Okay, when you complement with formal method, here you cannot find. Mostly some will not be detected. But when you complement with formal method, then you realize because formal method, mathematics, logic, true, false, yes, no, whatever, all those things. So the result there will complement this. You thought that what you are doing here are actually correct. But when you try to do the formal method, you found out that, oh, there is a problem with this way of writing, for example, of solving this problem. Okay? Then from there, you know that later, if you continue with whatever that you have, you will have problem later. So from here, when you complement with the formal method, you can detect the problem earlier. So when you detect the problem earlier, error prone, all this earlier, flaw, whatever that you found out earlier, then, okay, you resolve it, you solve it, the problem, everything. Then when you proceed, okay, so from here, the main purpose is to find the problem earlier. But because of you finding the error earlier, it will help you in terms of solve a lot of costing. Okay, a lot of expenses that you are going to use later. Okay, so that is actually another reason why it's actually useful to use formal method, especially when we talk about critical system. Okay, normal system like web-based, mobile-based, actually not really needed the formal method because all this system does not affect the human life. Okay, because when you do mobile-based, hang. You stop for a while, you didn't do that. Hang, right? But you are not going to die because the system hang. Okay, that is what we call as non-critical system. Okay? But when we talk about critical system, it's something that affects, for example, human life. Like the door just now, train just now. Somebody stand nearby the door, then accidentally the door open when the train, the train is actually moving. Okay? Fall down, for example. Okay? Die. So it's actually people will die because of the error there. Okay, so that is what we call as critical system. There's something that might affect the human life. That is a system that we call as critical system. So when you say earlier detection, error detection earlier and so on, that is one of the way. That is actually one of the usefulness of the formal method because we try to avoid this kind of problem. So we find the error earlier, solve it, then when you develop, when you actually deploy the system and so on, okay, the problem won't occur anymore. And then from there, actually, because the problem did not occur anymore, expenses from here will be reduced actually in terms of that. Of course, you cannot see as in terms of monthly expenses, but you will look at the whole system expense. expenses. Because when the manager, they how to say, they actually plan the expenses and so on, they have specific budget. So when you try to solve problem as early as possible, let's say you put 2 million, maybe the 2 million is not used all because of early detection, so you may have extra money there. Okay? So these are the things that will affect if you do formal method earlier. Okay? Yeah? So any more? What you can think of? Imagine system that people will die. So what do you think formal method can help you to solve this kind of problem that might occur during the
confidence.
sorry?
User confidence.
Yes, user confidence. One of it will be user confidence. Okay? Because especially the company who are asking you, okay, can you develop this kind of system within 2 years? Okay, we want to have this kind of system, blah blah blah, whatever lah. But this system will need to be a thoroughly checked because it involves human life, whatever. Okay, so let's say that those are the requirements from the clients lah, to your company. Then you do analysis and so on. Okay, so because when, like I told you just now, if you do normal like UML diagram, no problem, you can proceed. Okay, but at one point, okay, you cannot prove that your system is actually without problem. Okay, so that's why when you go for formal method, you, for example, you go for specification and verification together because this system is going to be critical because involves human life and so on. So you want to make sure that the customer actually very happy with your system. Then you added feature, formal method. Doesn't matter lah, formal specification, formal verification, you put that. So from there, when you normally nowadays a lot of companies they will show progress. Maybe 3 months, 6 months, it's up to the requirement of the agreement lah. Okay, so they will show. So during the meeting with the clients to show the progress of the system and so on, then they can show that we have done this, and then we can confirm you. I cannot say 100% lah. Normally we will say we can confirm you 99.999 for example lah. We cannot say 100% lah. So we can confirm that we have done checking with this. No problem, everything is okay and so on. So when the customer heard something like that, most of them will feel like, oh, okay, I don't have to feel like the system may cause me a lot of problems later. Of course, like I told you just now, it's not going to be 100% perfect. That's why even though our system really check, there will be at one point, sometimes there will be something wrong with it. But it's not going to be like gradually come up problem here, come up problem, come up problem. But even though our train there, maybe you see like some train that stop. Apa-apa, nothing. Just say that they have to do, because then after that they have to do maintenance. Because they might find out something wrong there. Okay, because the system is not perfect. But at least when you want to deliver to the customer, you can confidently say that we have done a lot of checking here, we have proving all these things, no problem, then they will feel confident with your system. Okay, so that is another reason. So those are a few things that you can find from the notes. So that's why for this one, I didn't do a lot of theory questions because the answer is just that I want to explain to you on how to answer this kind of questions. If this kind of questions, like say, similar question whatever in the exam or in the test, so you have to relate. Because the question is relate to the critical system. So you relate to the critical system. Your answer relate to the critical system. Okay? So that is number one. Any more answer for number one here? Oh, okay, or you can find from the notes. Yeah, you can find from the notes. Other than that, there are a few more answers there. Then you can explain using your own words. Okay? So relate to the critical system. Yeah? So, okay, this one is actually the one that I explained just now about formal verification and formal specification. So, just now I said the word. Some students, they are like confused. Specification and verification. Just look at the word there. Specify and verify. Verify means you want to check correct or not. That is verify. Like normal verify. So it means that when we talk about formal verification, verify, you are talking about whatever that you use, whatever that the statements that you write there, you must check whether correct or not. Must prove that is correct. Must check. So that is verify. So formal verification is actually you use formal methods. Okay, you use formal method, mathematical notation, whatever, formal proof, whatever. Okay, to check on whatever that you are doing in the system. Okay, so checking lah, verify, proof whatever that you are doing are actually correct. So that is formal verification. Whereas formal specification, specify. Specify means specification. I think all of you know about specification. The word specification means from the requirements gathered by the customer. Okay, when you gather requirement, and the requirement will be jumbled up all together, mixed up together. Okay, so you have to check on the requirement. Okay, then you sort out, right? So it means that I didn't say sort out. It's like you rearrange it according to what you want. Which are have highest priority, second priority, and so on. So those are actually specifying. Means that you get all the requirements from the clients and so on. Will be mixed up. Some say this, some say this. So you have to find something which are related to what you want or what they want. Okay? Then when you have done all this arrangement accordingly, so this is what we call as specification. Okay? So that's why when you do later SRS whatever, you have what we call as software requirement specification document. Is specified. So you list down all the requirements accordingly. So that is specification. Means that rather than you have the data which are mixed up together. So when you are in the specification, you have like we call as a very standardized specification of requirement. So and then all grouped together accordingly. So this is what we call as specification. So formal specification is actually you are looking at the requirements and then you are going to produce, okay, using formal methods to check on this formal in this requirement using formal methods. So you specify the requirement in formal method. So that is what we mean by formal specification. So if you check, differentiate between these two, one of that it will be the meaning. Another one is where you found this formal method. So formal specification, as I told you just now, will be during the analysis and design phase. Okay, analysis and design phase. Whereas verification, normally I didn't say that it won't appear in the design because sometimes you will verify something. Just that mostly it will appear during testing phase. Okay, during testing phase. So that is formal verification. Okay, so the easiest is to look at the word okay, when you want to answer this kind of question. And then so this one, benefits of requirement specification can be achieved through formal specification. It's actually similar I think you can relate to this one, but this one you relate to the critical system. For this one, you can actually, when we talk about requirement specification, one of it we can talk about clarify the requirement, okay, by removing any ambiguity, okay, all those things. Okay, so one of it will be in terms of clarify the requirements. Okay, you are trying to clarify the requirement. Okay, because we are talking about specification here. Specification is more on the requirement. We are talking about the requirement. So one of it will be the main benefit is you want to clarify the requirement. Okay, because you use logic set whatever easier to clarify the requirement. And then also remove ambiguity. Okay, ambiguity is something that here say 3 seconds, here say 5 seconds. Then you check, okay, how come different? Then in order to actually confirm, then you can talk to the clients again, 3 or 5, something like that. So because you can remove any ambiguity. So from there, when the client say, oh, 3 seconds, not 5 seconds, then you know lah, one requirement can be removed, which are not the correct one. So you remove any ambiguity in your requirement. Other than that, what do you think? What do you think? What do you think? Yes, you can say that better communication with the client. Okay, because you can relate to this now also. Okay, with the critical system, but of course here we how to say we didn't concentrate on the critical system. We are talking about formal specification, but you can communicate easily with the clients if the information, let's say just now ambiguity, right? So you know which part are ambiguous. So you can actually communicate with the client directly. Okay, what is actually the correct one? So easily you can communicate with them. If let's say you use normal, sometimes the clients will be blah because you don't have specific requirement. But when you use formal method, formal specification in this case, okay, because we are talking about the requirements, so you can be specific on it. So when you be specific, then you can communicate easily with them. You can get the correct, not the correct answer. That means that you can actually check in with them. Okay, which one do you want? Okay, we have this, but we are not so sure what is your requirement. So from there, you can communicate easily with them to get the correct answer. Okay, you can get the correct answer. Okay, any more? So they can understand better lah. When you communicate with them better, of course they will understand better. Okay, so those are a few that you can look into the answers. Okay, the next one, 4, 5, 6. Okay, 4, 5, 6 is actually you have learned before in your mathematics course before previously. So in this subject, I just want to recall whatever that you have learned before, because later you are not going to do this lah. Later you are not going to do this. Just that some of the symbols here will be used later in your formal method. Yeah. So using set display. Set display means, you see the word set. Set display means curly braces. What you did last time now. Okay. Set display means curly braces. Okay. So let's say you want to show the days that you are in the college or in the university. So how to write normally, you just put, let's say I put Monday, Tuesday, whatever lah, Wednesday, so on. So the way to write is by using curly braces. This is actually what we call a set display notation. Okay, so I put here dot dot dot, you can add your own data there. This is example only. Okay, this is example only on how to write the set. When you see this, because later in Z schema, we are going to use a lot of set notation. Okay, we are going to use a lot of set notation. So we have to recap whatever that you have learned previously. Okay, so you actually have the knowledge. Then we are going to correct again whatever that you learned last time. Okay, to the surface again, so that you can use these for your formal method course later. Okay? The next one. Set of digit use a base 2 binary will be 0 and 1 only lah. Okay. Binary 0 and 1 only. Can see Okay, colors rainbow, write down yourself. I also don't remember color rainbow. Seriously, I cannot remember. So you write down this answer. answer. Okay, rainbow color. I provide the question, but I also cannot remember the answer. Okay, so I hope that you will remember lah. If cannot, you find from the internet lah. What are the rainbow colors? I also cannot remember. So you just put inside the curly braces lah. Whatever that you have, you put inside the curly braces. Separated by comma. Separated by comma. Okay, so that is what we call as set notation. Okay, set display notation. Okay, later also in your Z schema also, you will have logic true false. Means that when you do something like you need to check, then you have to do true false. Means this right side is it equivalent to right side. So true or false. So something like that. Okay, so it's logic. So you have to remember in terms of that lah. But I think logic very easy because sometimes when you write coding also less than, equal than, then you want the answer to be true or false. So I think all of you should have the knowledge already about the logic lah. Okay, so but this one, okay, is at least something that later you are going to use a lot. So this symbol we call as member of, okay, member of inside your maths also they call as member of, right? Or what? This symbol. Inside the maths, what do we call this? Member of? Element of. What? Which one? Member? Element? The other, for Z, we call as member of or element of, no problem. It's the same thing. Means that you have a set of data, then you want to check this data, is it exist in this set of data, right? So we use member of or set. So this symbol of member of. So what we are going to do, let's say this is a set of data that you have. So we are checking this data. Remember in Z schema, okay, in Z schema, small letter, capital letter are two different things. Okay, so when you use small letter, you want to check the data inside here also must be small letter. If capital letter, totally different already. Okay, so in this case, we have N here and we have N here. So exists, So what this statement means is actually this data we are checking. The statement here when we read in Z schema later, the meaning of this statement is, does this data exist or not in this data? That is what we mean by the statement in Z schema later. Okay? Does this data exist or not in this set of data? Okay? So when you see this data exist, then the answer is true. Okay, the answer is true. Okay. So the second question also similar. Does this data exist in this set of data? True or false? Does this data exist in this set of data? True or false? What do you think? False. Okay, the answer is false. Even though you have key here, but one is capital letter, one is small letter. Two different answers also. Okay, so this answer is false. Okay, for this one is false. Okay, 0 is not a member of empty set. Empty set means empty, 0 is a value. So it's not a member of empty set. So the answer here is true. Okay, it's true. 3.142. Okay, so another thing that you have to know about Z schema, we cannot represent decimal points. Okay, so the only symbol that we can use is either Z or N. These two need to represent integer data. We cannot represent. Let's say you want to have price 9 ringgit 90 cent. Cannot. It won't be 10 ringgit. Straight away 10 ringgit. You cannot have decimal points. Okay, when you do Z schema, remember this. In Z schema, we have only Z or N. Z whole number. So Z is number can be positive or negative. Whereas n is also integer number, means that natural number. So this one will be from 0 onwards. Okay, from 0 onwards. So if you look at this, of course, false. This one false. This one also false. Okay, the only true will be A and E only. The rest are false. Okay, correct? A true, B false, C true, D false, E also false. Okay? Okay, get the answer? Okay, the next one. Okay, the last question. So, also we are going to use set display notation. So, this is, you will find also in Z schema later. Okay, of course, because you haven't learned about Z schema, whatever the notation here, I will use like normal mathematics first. Okay, so if you look at this style, when you see this, you have in front here, and you have the condition here. This is what we call the whole statement here. We call as set comprehension. Okay, we call as set comprehension.
Turun lagi.
Okay, so we call this as set comprehension. This one. So later when you learn in the lecture, okay. So when you learn this in the lecture, okay. So there are another symbols. Okay, another symbol. Okay. So for this one, okay, okay. So this is something like variable declaration. Okay, variable declaration. Like you do your programming, right? So you have variable declaration. So this in front here is something like variable declaration. Okay, so what we do here, and here is variable. Okay, your variable, your identifier. Z is your type, like integer, double, all those things. So in this case, we have variable n of type Z. Z is integer just now, right? Positive or negative. Okay, n is of type Z. So in this case, this is bar. Bar means whatever come here is the condition of your statement here. So what it means here, n here must be greater or equals to -1, and this conjunction, n less or equals to 1. Means that we are trying to find what is the end result here. What is the end data here? Okay, so n can be positive or negative, but the condition of n now is greater than 1 and less than 1. So meaning that the n that we have, okay, so the way to write using the schema definition, the n data that we have double equal. Because in programming, double equal means compare. Here different means define as. So you have -1, 0, 1. Okay? -1, 0, and 1. Okay? So that is what you mean by this statement. Means that this is your variable declaration, and then from here, this is the condition of your variable. Okay? So from here, we are saying that our n is actually, so use double equal, means define as, so our n can be either -1, 0, or 1. Okay, our n can be either -1, 0, or 1. Okay, so same thing for this one. Okay, so similar, just that now our variable is d equal. Then you have 1, 2, 3, 4. Actually, 5 elements. Got more than that, you put dot lah. But here I just put all lah. Just 7 only. Okay? how you get the answer. Even though here it shows or, this junction or, so the answer still will be okay? And how about the last one? What do you think will be the answer for the last one? What do you think? Okay. Let me show you. Let me explain to you the meaning. So you have modulus, you have divide. Okay, these two symbols, these two keywords, okay, need to be used with integer only. So this is that, integer, right? So mod and divide can be used for n or z. So can be used for z. Okay, divide. You know divide, right? Integer divide to another integer. Okay, you get the division without the remainder, right? So that is the answer for divide. When you want to get the remainder, you use modulus. Okay, so if you were given this statement, what will be the answer of your n here? What do you think will be the answer for n here? Is it 10 only? Here, you have less than 10. You have less than 10. So meaning that you start from 0. N greater than 0. 0 modulus 10, 0 also. 0 divide 10 also 0. So you start from 0, you get 0. Then after that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? 10 is greater than 0. 10 modulus 10, the answer is 0. 10 divide 10 less than 1. True. So 10. And is it n like that? No, So you continue. 11, 12, 13, 14, 15, 20. See, 20 modulus 10, 0. 20 divide 10, still less than 10, correct? So 20. Then actually you will have this until 100. 110 is not going to be the answer already. Increase by 10, So 110, correct, is correct. Here also correct. But 110 divide 10, the answer is 11. So wrong already. So that's why the last value is 100. Okay, Understand, Any of you have problem understanding this one? Okay, Because this is n condition, This is n condition. This is n condition. So all must be true. Okay? All must be true. So when all must be true, let's say 21, let's say talking about 21. 21 greater than 0, correct? No problem. 21 modulus 10 equal to 0. No,
One.
You have remainder 1, right? So this one wrong already. So 21 is not the answer. Then after that you go for 22. Correct? 2. Wrong also. 23. Wrong also. 24 until 30. 30, true. 30 modulus 10, 0, 30 divide 10. Got 3, right? 3 less than 10. Correct. So you can put 30. So that's how you put like your mathematics, So logic. So this is logic. Okay? So of course this one we are using like number here. Later you are going to use like variable like programming. Okay, so there may be some things that you have to add here and there. But the statement here, okay, the statement here we call as set comprehension. Okay, so when next week lecture, I will start a little bit. Hopefully, can go up to set comprehension already. Okay, in the lecture next week. Okay, any question? So tutorial 2 actually start with the Z schema already. So tutorial 1 is only introduction. So just for you to understand. So any question? No question, ah? Okay lah, if no question, we will